The next topic I am going to discuss is differentiation of implicit functions. Now, first of all, I will tell you what do we mean by implicit functions. Now, first is functions of the type y is equal to fx. When y is explicitly expressed in terms of x, y is explicitly expressed in terms of x. Such functions are known as explicit functions. And if a function is of the form fxy is equal to 0, that is, y has not been explicitly expressed in terms of x. It is not easy or it is not possible to express y in terms of x. Then such functions are known as implicit functions. For example, x square plus x square y square plus y cube. This is equal to 0. Now, y has not been solved in terms of x. Y has not been expressed in terms of x. Such functions are known as implicit functions. Or sine of x square plus y square is equal to x cube y cube. Then this function is again an implicit function. Second point is dy by dx into dx by dy is equal to 1. dy by dx into dx by dy is 1. That is, dy by dx is equal to 1 upon dx by dy. And third point is d by dx of say y cube. d by dx of y cube will be, we are differentiating y with respect to x. So we are using the formula for x cube for y cube. Formula for x cube is being used for y cube. So what we do is, now differentiation of x cube is 3x square. So this will be 3y square into differentiation of inner function. Inner function is y. So dy by dx. dy by dx. And d by dx of say sine x square plus y square. X square plus y square. This will be differentiation of sine is cos. Cos x square plus y square. Differentiation of sine is cos, and we are using the formula for sine x for x square plus y square. Formula for sine x is being used for sine of fx. So we must take differentiation of fx. So we will have d by dx of x square plus y square. X square plus y square. And this is equal to cos of x square plus y square into differentiation of x square. d by dx of x square is 2x. And differentiation of y square is 2y. And we are using the formula for x square for y square. So differentiation of y, dy by dx. This term will be extra. And in a different notation, say if s is a function of say t. S is a function of t. For example, d by dt of s square plus t cube s square. This will be the differentiation of s square. S square will be 2s, and differentiation is with respect to t. And we are using the formula for t square for s square. So we must take d by dt of s. Formula for t is being used for s. Formula for t square is being used for s square. So we must take ds by dt plus, now this will be product of two functions. So first function t cube into d by dt of s square plus s square into d by dt of t cube, and this is equal to 2s ds by dt plus t cube into differential of s square will be 2s into ds by dt. Formula for t square is independent variable is t. Formula for t square is being used for s square. So we must have ds by dt plus s square into, now here formula for t is being used for t. So differential of t cube is 3t square. Even if I take the differential of the inner function, that is d by dt of t, it will be 1. So this is the differentiation of this. To find dy by dx from an implicit function, this generally involves two steps. Step 1, differentiate both sides with respect to the independent variable x. If it is t, differentiate with respect to t. It is x, differentiate with respect to x. Differentiate both sides with respect to the independent variable x. If it is t, differentiate with respect to t. And step 2 will be solve the resulting equation in dy by dx, and we will get the value of dy by dx. With this background, I take up the first question. Now in this question, we are given the implicit relation this, and we have to find dy by dx. First step will be differentiate both sides with respect to x. Differentiate both sides with respect to x. What we get is d by dx of x cube plus y cube is equal to 3a is constant, d by dx of x y, and this will be equal to, now d by dx of x cube is 3x square, and here inner function is y, so differentiation will be 3y square, same formula, and extra will be dy by dx because a formula for x is being used for y. So this is the differentiation, and here it will be 3a whole into first function into differentiation of second, first function into differentiation of second plus second function into differentiation of first, that is x. Now these three cancels throughout, and we are left with x square plus y square dy by dx is equal to, I am opening this bracket, this will be ax into dy by dx plus ay into dx by dx is 1 and dx by dx is 1. We have completed the first step, that is differentiate both sides with respect to x, and second step is solve the resulting equation for dy by dx. We will now solve this equation for dy by dx. Bring all the terms involved in dy by dx to one side. So this will be y square dy by dx. This term, and bring this term here, minus ax dy by dx. All terms involving dy by dx on one side, and this will be taken to the other side. This will be ay minus x square. So dy by dx is common, and we get y square minus ax is equal to ay minus x square. So dy by dx is equal to ay minus x square whole divided by y square minus x. So this is how we get the value of the derivative. Differentiate both sides with respect to x and solve the resulting equation for dy by dx. Now next question is, we are given this relation and we have to find dy by dx. So what we do is, we will differentiate both sides of this equation and simplify it, and then solve the resulting equation for dy by dx, and we will get the result. You can try this question yourself on similar lines. Next question is, we are given sin y is equal to x into sin a plus y. Prove that dy by dx is equal to sin square a plus y over sin a. We are given this equation and we have to find dy by dx. So what we do is, we differentiate both sides of 1, differentiate both sides of 1 with respect to x. We differentiate both sides of 1 with respect to x. What we get is d by dx of sin y is equal to d by dx of x into sin of a plus y. Differentiation of this will be, differentiation of sin x is cos x. So differentiation of sin y will be cos y into differentiation of inner function, that is y, dy by dx. This is equal to, now this is product of two functions. So what we will have is first function into d by dx of sin of a plus y, plus second function, that is sin of a plus y into d by dx of x, that is 1. So this will be cos y into dy by dx is equal to x into sin of, differentiation of sin of a plus y. Sin of a plus y will be cos of a plus y into differentiation of inner function, that is d by dx of a plus y into differentiation of, formula for sin x is being used for sin a plus y. So differentiation of sin x is cos x into d by dx of inner function, that is a plus y, plus sin a plus y into d by dx of x is 1. So what we get is cos y into dy by dx is equal to x into cos of a plus y into, now differentiation of a is 0, a is a constant, so differentiation of constant is 0 and d by dx of y is dy by dx plus sin of a plus y. Now this is the equation we get after differentiating both sides of 1 with respect to x. Now next step will be solve this equation for dy by dx. What we get is cos y into dy by dx minus, bring this term to the other side, cos a plus y into dy by dx is equal to sin of a plus y. Dy by dx will be common and we are left with cos y minus x into cos of a plus y. This is equal to sin of a plus y. Dy by dx is equal to sin of a plus y whole divided by cos y minus x into cos of a plus y. And this is equal to, now this is the required answer. We have to prove that dy by dx is sin square a plus y over sin a, but we are getting the answer as sin a plus y over cos y minus x into cos A plus Y. So what is the difference between these two answers? Here there is no x involved, and here we have a term involving x. So we have to eliminate this x in order to get this answer. So generally in such questions we make use of the given relation. From given relation, x will be sin y over sin A plus y, and substitute this value of x in this equation, we will get the result. Generally we use in such situation when we do not get the answer required in the question, we generally make use of the given equation. So from the given equation we have 1 implies x is equal to sin y over sin A plus y. So what we get is this is equal to sin A plus y whole divided by cos y minus x is sin y over sin of A plus y into cos of A plus y. So this is equal to, now take the LCM. So this will be sin of A plus y whole divided by, this is the LCM, sin of A plus y. Sin A plus y is the LCM. So we get sin of A plus y into cos y minus sin y into cos of A plus y. This is equal to, you can see the last step on the side sheet. What we get is sin of A plus y whole divided by, this will be on the side sheet, you see the last step, it will be sin A plus y into cos y minus sin y into cos of A plus y. That is sin A cos B minus cos A sin B. So we are getting the formula for sin A minus B. So this will be sin of A. A is A plus y. Sin A minus B. B is y. We are getting sin A plus y into cos y minus cos A plus y into sin y. You can see the side sheet. This whole divided by sin of A plus y. So this term will go up. We will have sin of A plus y whole square. 1 sin of A plus y we will get from the denominator. So this will be equal to sin of A. Sin square A plus y is equal to sin of A. And this was the required answer. Right hand side. Hence proved. An alternative method is, we are given sin y is equal to x into sin A plus y, and we have to prove this. This method is better if it strikes you. What we see is, we are given this relation sin y is equal to x into sin A plus y, and we have to prove this. So what we notice in this result, there is no term involving x. There is no term involving x. So what we do is, from 2 x is equal to, we take this term to the other side. What we get is x is equal to sin y over sin of A plus y. Sin y is equal to sin of A plus y. Now differentiate this with respect to y. We will get dx by dy, and we know dx by dy is 1 upon dy by dx. We will be able to change it into dy by dx. So this is equal to, now here we have to differentiate this. So we will use quotient rule. Gx whole square into gx into differentiation of f dash x minus fx into g dash x. So we are differentiating with respect to y. So it will be gy whole square. It will be gy whole square into gy into d by dy of fy minus fy into d by dy of gy. Fy into d by dy of gy. You can see the side sheet for the formula. So this is equal to sine of a plus y into d by dy of sine y. Now we are differentiating sine y with respect to y. So this will be cos of y. Formula for y is being used for y. So there will be no differentiation of inner function. It will be dy by dy. That is 1 minus sine y into differentiation of sine. Differentiation of sine is cos of a plus y into differentiation of inner function, that is a plus y. Differentiation is with respect to y. So this is equal to this, and this is equal to sine of a plus y into cos y minus sine y into cos of a plus y into, now d by dy of constant is 0 and d by dy of y will be 1. d by dx of x is 1. So d by dy of y will be 1. This whole divided by sine square a plus y. So this is equal to, this is sine a cos b minus cos a sine b. So we are getting the formula for sine a minus b. So this will be sine a minus b. This is a, this is b. This is a, this is b. Whole divided by sine square a plus y. And this is equal to, now this is y cancels and we get sine a over sine square a plus y. So we get dx by dy is equal to this much, and we require dy by dx. So dy by dx will be reciprocal of this. This will be reciprocal of this. So this will be sine square a plus y whole divided by sine a. Hence proved. Hence proved. Now in this question, we are given this equation and we have to prove dy by dx is equal to minus 1 over x plus 1 whole square. So we are given the equation x into 1 plus y under the root plus y under root 1 plus x is equal to 0. Now in implicit functions, if any simplification comes to your mind, then carry it out in the given equation. It is generally useful to carry out the simplifications. As we did in the previous example, we will carry out the simplification of this equation first and then differentiate it. It is generally shorter. So what we do is we write this equation as x under root 1 plus y is equal to minus y under root 1 plus x. Square both sides. What we get is x square into 1 plus y is equal to y square into 1 plus x. Open this bracket. This is x square plus x square y is equal to y square plus y square x. Now if I take this term to this side and we'll get x square minus y square. X square minus y square can be factorized into x minus y into x plus y. And if I take this term to this side and take xy common, what we get is we will get y minus x. So x minus y will cancel from both sides. So what we do is we take this term to this side. This is equal to y square x, and take this term to the other side, minus x square y. Now this can be factorized into x minus y into x plus y, and this is equal to x, y is common, we get y minus x. We get y minus x. Now x minus y cancels from both sides. This cancels with this. We get minus 1 because it is x minus y, and here it is y minus x. So we'll get minus 1. So we are left with x plus y is equal to minus x y. Now differentiate both sides with respect to x. So what we get is differentiate both sides with respect to x. What we get is d by dx of x plus y is equal to minus d by dx of x y. So d by dx of x is 1 and d by dx of y is dy by dx. This is equal to minus, and now we will use product rule. First function into differentiation of second, that is y, dy by dx, plus second function into differentiation of first. So differentiation of first is 1. Or you can say fx into g dash x plus gx into f dash x. We solve this equation for dy by dx. Take all terms involving dy by dx to left hand side. So this will be plus x into dy by dx is equal to minus y minus 1. This is minus x into dy by dx. I have taken this to the left hand side. So we get x dy by dx. And this term has been taken to right hand side. So this is minus y minus 1. So what we get is dy by dx is equal to minus y plus 1 whole divided by x plus 1. Dy by dx is common, we will get 1 plus x. I have divided by 1 plus x. So this is equal to, now the answer is in terms of x. So we will put the value of y in terms of x. So this equation is, say, 1. Now 1 implies y plus xy. I am taking this to the left hand side and this to the right hand side. This is minus x. So y into 1 plus x is equal to minus x, or y is equal to minus x over 1 plus x. So put y equal to minus, because answer is in terms of x. So we eliminate y. So y is equal to minus x over 1 plus x plus 1 whole divided by x plus 1. So this is equal to, this is x plus 1, and LCM of numerator is 1 plus x, and we get minus x plus, this is 1 plus x. This x cancels with this. We are left with minus 1 over 1 plus x, and this term combines into, simplifies into minus 1 upon x plus 1 whole square. This is minus 1 upon 1 plus x whole square. Hence proved. Another question is secant of x plus y over x minus y is given to be a, and we have to prove dy by dx is this. Now in this question we again simplify the given equation. We can write this as x plus y over x minus y is equal to secant inverse A. This is equal to secant inverse A. Say this is equal to k. This is constant. I am substituting this constant by k. K is equal to secant inverse A. Now what we do is, I can write this k as k over 1. Now what we do is we apply componendo and dividendo on both sides. So what we get is, we will write x plus y over x plus y. Numerator on both numerator and denominator. And from here I will subtract the denominator, and here I will add the denominator. Numerator minus denominator plus denominator. And similarly we carry out the simplification on right hand side, k, and we have subtracted the denominator here and added denominator. It's same should be done on both sides. This minus this plus this, k minus 1 over k plus 1. This is componendo and dividendo, and we get 2y whole divided by this y cancels with this, and we get 2x. This is equal to k minus 1 over k plus 1. Call this as, say this is 1, call this as 2. So what we get is y is equal to k minus 1 over k plus 1 into x. Now we differentiate this equation. We get dy by dx is equal to k minus 1 over k plus 1 into dy by dx of x is 1. And this is equal to, we have to prove that dy by dx is y by x. So we get dy by dx equal to k minus 1 over k plus 1. But k minus 1 over k plus 1 from this equation is y by x. So we get y by x. Hence proved. Now this and the next question you can try yourself. If you are not able to find the solution, then only see the solution. If you are not able to solve them, then only see the solution. I am giving the solution, but you first try them, and then if you are not able to solve them, then only see the solution. Now here y is given to be b tan inverse x by a plus tan inverse y by x, and we have to find dy by dx. So what we do is, first of all we will simplify this relation. If we directly differentiate it, what we will get is y dash will be b into differential of tan inverse x will be 1 over 1 plus x square, 1 plus square of this into dy dx of inner function, which will be very complicated. So first of all we will simplify this relation. Let y by b is equal to this b to the other side. We will have this equal to tan inverse x by a plus tan inverse y by x. Take this tangent to the other side. We will have tangent y by b will be equal to x by a plus tan inverse y by b. What we do is we take tangent of both sides. Then this will be tangent of y by b, and tan of tan inverse will be identity function, and I of x is x. So this will be tan y by b is equal to x by a tan inverse y by x. Now differentiate both sides of this equation. Differentiate both sides with respect to x. What we get is differential of tangent y by b will be secant square y by b into differential of inner function, that is t by dx of y by b. Secant square y by b into differentiation of any function, that is y by b, is equal to. Now differentiation of this will be 1 by a plus differentiation of tangent inverse y by x is 1 over 1 plus y by x whole square into d by dx of y by x. That is secant square y by b into, this will be 1 by b dy by dx. B is constant, therefore 1 by b, and differentiation of y is dy by dx. This is equal to 1 by a plus, now LCM of this is x square. So we have x square plus y square into differentiation of this. Now denominator square, x square x into dy by dx minus y into differentiation of x is 1. So what we get is 1 by b secant square y by b into dy by dx is equal to 1 by a plus, this will be x square over x square plus y square into, and this will be x square x into dy by dx minus y. Now take terms involving dy by dx to one side. What we get is 1 by b secant square y by b. This is the term involving dy by dx, and on this side the term involving dy by dx is minus x square over x square plus y square, x square over x square plus y square into x dy by dx over x square. So this will be 1 by x dy by dx. dy by dx is common. So this is 1 by x into dy by dx. This is common. This is equal to, now terms not involving dy by dx. This is the term not involving dy by dx. And from here we have the term not involving dy by dx will be x square y. X square y over x square plus y square into x square. This x square cancels with this, and we get 1 by b secant square y by b minus x and x cancels, and we get x over x square plus y square. This into dy by dx, and this is equal to 1 by a minus y over x square plus y square. Take LCM of this side. What we get is b into x square plus y square. b into x square plus y square, and this will be x square plus y square. b cancel, and we are left with x square plus y square. So this will be x square plus y square into secant square y by b minus, now this and this cancels, we get b minus b x into dy by dx. This is equal to, take LCM of this side also, a into x square plus y square. This will be x square plus y square minus a y. Now this cancels with this. Now I will take this term to the other side. So this will be dy by dx is equal to b by a, I am taking this b to the other side. So b by a whole into x square plus y square minus ay whole divided by this term. That is x square plus y square into secant square y by b minus bx. So this is the answer. B by a into this over this. This is the answer. This question you can try yourself. Again, you can try this question, and if you are not able to solve it, then only see the solution. I am giving the solution, but first you try it and then only see the solution. So we are given x by y plus under the root y by x is equal to 6. We first simplify this equation. What we do is squaring both sides. Squaring both sides. Squaring both sides, what we get is x square plus y square plus 2ab is equal to square of 6 is 36. So what we get is this is equal to 34. This is equal to 34. Now take the LCM, we get x square plus y square whole divided by xy is equal to 34. That is x square plus y square is equal to 34 xy. So now this relation is much simpler than this, because if I differentiate it here, what we will have to do is first x by y to the power of half. So differentiation will be half x by y to the power of half minus 1 into d by dx of inner function. And inner function you will have to use the quotient rule. And here also first power rule and then the quotient rule. So question will be complicated. But from here you directly differentiate both sides. Differentiate both sides. What we get is 2x plus 2y into dy by dx. And this is equal to 34, and here we will use the product rule. First function into differentiation of second plus second function into differentiation of first. So what we get is 2x plus 2y into dy by dx. This is equal to 34x into dy by dx plus 34y. Now what we do is we take the terms involving dy by dx to one side. So this will be dy by dx, and the term involving dy by dx here is 2y, and on this side we have minus 34x. And this is equal to 34y, and take this to the other side, minus 2x. So this will be dy by dx is equal to 2 into, now 2 is common, so we get 2 into 17y minus x whole divided by 2 is again common, and we get y minus 17x. This 2 cancels with this. Now take y common from here, because we want the answer y by x. So take y common, what we get is 17 minus x by y. And from here take x common, we will have y by x minus 17. Now answer required is y by x. So this term should come out to be equal to 1. These two terms should be equal. Now what we see is this is equal to y by x into. Now from 1 what we get is x by y is equal to 34 minus y by x. So this will be 17 minus 34 minus y by x whole divided by y by x minus 17. I am changing this in terms of y by x so that these two terms can cancel out. So this is equal to y by x into, now 17 minus 34 is minus 17. So this is minus 17 and this is minus minus plus y by x. So y by x minus 17 divided by y by x minus 17. These two cancel and we get y by x also. So here you must note that the answer required is y by x. So take y common and from here take x common. Now these two terms should cancel out. So I must change x by y in terms of y by x or y by x in terms of x by y. So what we do is I substitute x by y in terms of y by x from this equation and get the result. This step is important.